All right, so today we're going to start Chapter 1 with some definitions of functions. These are rules that you should already know and definitions that you should already know from your Algebra 1 experience. We're hoping to remind you of this in the beginning of Chapter 1 before we move on to more difficult problems. The definitions that you see here should be written in your notes in your own handwriting. If you need to pause the video here to copy this down, please do that. Okay, one more definition of a function. Again, if you need to pause the video to write this in your notes, please do so. Also, write the question and copy the table in your notes in your own handwriting. If you need to pause the video, please do so. I'm going to go ahead and explain this question here. Is the relation a function? The definition of a function, each member of the domain is mapped by a rule to exactly one member of the range. Here, the rule for the relation is shown as a table. There are many different ways that you can show rules for relations. In this case, we're doing it by a table. There's an input and an output listed. So we have to figure out if each member of the domain is mapped to exactly one member of the range. So 1 is mapped to 8, 2 is mapped to 7, 3 is mapped to 8, and 4 is mapped to 9. So each input, these are 4 different inputs, gets its own output. So yes, this is a function. Okay, problem number 2, and again, make sure that you have the table in your notes. If you need to pause the video to put the table in your notes, please do so. She's not here. All right, sorry for that little interruption. Here we've got 10 is mapped to 8, and we also have 10 is mapped to 9. So the same input has 2 different outputs. This is what you want to look for to see if the relation is not a function. If more than one member of the domain, in this case 10, if a member of the domain, in this case 10, has 2 different mappings to a member of the range, that makes it not a function. All right, so there we showed some relations that were defined by tables. There's, again, lots of ways to define relations and functions. Here, we've got an algebraic rule describing a function. And this is what you're used to seeing most often in algebra, is an algebraic rule that defines a function. Here, we've got a function whose name is g, where the input is x. And then there's the rule that explains how do you get the output when you're given the input. So if I want to evaluate the function g when the input is 1, I'm going to substitute the 1 into the rule where x is. So here I've got the square root of 2 times 1 squared plus 7. And then just use your order of operations and simplify this to find the output. So 1 squared is 1, 2 times 1 is 2, 2 plus 7 is 9, and the square root of 9 is 3. So, therefore, the value of the function g when the input is 1, the output is 3. And that's how you write your answer. For problem 2, we're asking what's the value of the function g when the input is -3. So I input a -3 where the x is into the rule for the function. Now, you might need a little reminder that if you're substituting a negative number, you need to substitute it inside parentheses. That will make a difference when you're evaluating exponents. So, -3 squared is 9. 2 times 9 is 18. 18 plus 7 is 25. And the square root of 25 is 5. So the function g, when the input is -3, the output is 5. Last one. What is the value of the function g when the input is